In this video, we introduce Tagnoo, a new type of computational plywood augmented with RFID tags for sensing users' daily activities. Unlike existing computational materials, Tagnoo was designed to seamlessly integrate into traditional woodworking practices, allowing woodworkers with no technical background to effortlessly create room-scale smart environments. Plywood is a durable and flexible material composed of bonded thin wood veneer layers. It is a common material widely used in creating household items such as furniture, decoration, and home infrastructure. While previous research has explored the augmentation of plywood with sensing capabilities, none of the existing approaches are wireless, battery-free, and capable of withstanding typical woodworking operations such as sawing, nailing, and screwing. Tagnoo incorporates a grid of RFID tags within a plywood panel, enabling it to sense RF-absorbing objects, such as a laptop and its user, when in close proximity or direct contact with the plywood surface, without the need for battery power or wired connections to computational or data communication devices. The fabrication process of Tagnoo panels involves a four-step procedure. Firstly, a unique ID is assigned to the first half of the electronic product code for each tag using a handheld RFID writer. The tag ID encodes the sequence number and the density of the tags within the plywood panel. Subsequently, the RFID tags are attached to the plywood substrate based on the desired density, following a gluing strategy outlined in the paper. A thin veneer layer is firmly affixed on the top of the tags, and the glue is left to dry for 24 hours. Finally, a layer of water-based finish is applied to the surface of the plywood panel, providing protection and a visual appeal. We demonstrate how Tagnoo can be used to create a smart office environment using traditional tools such as a saw and screws. This process involves cutting the Tagnoo panel into the desired size and shape for different types of furniture and floors. The completed panel edges are then smoothed using a sander. Pilot holes are created using a drill at predetermined locations. Finally, different furniture pieces are secured together using screws. During this process, most tags can remain undamaged, as detailed in our paper. We showcase multiple use scenarios of Tagnoo using the constructed environment consisting of a desk, chair, bookshelf, and floor. In this environment, the desk and the chair can detect and record events such as laptop usage durations and idle times. This information can be utilized to gain insights into the user's work practices, facilitating personal reflection and potentially providing insights into the user's psychological state during work. Additionally, the bookshelf can sense and log the user's reading habits by tracking when the user takes and returns their favorite book. Disruptions in this routine, particularly during busy week before school project deadlines, can be logged for later review. Furthermore, the desk can sense the placement of everyday objects, such as a lunchbox. It can differentiate between an empty lunchbox and one filled with rice. It can also detect the user's chocolate bar. Such information can be used to infer details about the user's diet. Lastly, the floor can detect whether the user is standing, sitting, or lying on it. When combined with the duration of the user's preferred floor-sitting exercise routine sensed by the floor, and the diet information sensed by the desk, the system can provide insights into the user's health, well-being, and lifestyle choices. For more information of Tagnoo, please see our paper.